What you're seeing here is the end-to-end workflow to chat with any PDF and image files using large language model. And this is what we're going to build together in this tutorial. If you're ready, let's get started. Once we receive the input file, the first thing is to identify the type of that file, whether it is a PDF or an image. And the second step is, depending on the type of the file, extract the content using the relevant function. And once we have the content in a raw format, then we proceed with splitting that data into multiple chunks. And those chunks will be provided to a chunk transformer. The goal of a chunk transformer is to create an embedding of each of these chunks, which are then stored in a vector index. Once we have those 5 steps, then the user will be able to provide a query. Once the user's query is received, then the response is provided in a JSON format. So this is the complete workflow to chat with any PDF and image file. With this understanding, now we can dive deep into the coding part. Here are the main modules that are required, and I have already installed them, so I'm not going to go forward with the installation process. Once these modules are installed, the first step that we have in the workflow was to identify the type of a given file. And this is the helper function used to perform that task. So we are using a module called guess from the file type library. And with guess, we provide the path to the file. And this is going to provide what we call, a variable that I have called guess file. And this guess file is going to generate an information about the extension of the file. And since I am interested in 2 main files, the PDF and images, and now we check if the extension of the guess is PDF, then file type is going to be PDF. Otherwise, if the extension type is in the image type that I have mentioned here, then the file type is going to be image. And otherwise, the file type is unknown, and we finally return the type of the file. And let's see what this gives by using this file on the 2 files that we're interested. For the record, we're using 2 different files. The first one is the transformer paper, which is a 5 pages document. And the second file is this image file about, information related to my Medium articles. And here we have the path to both files, the research paper and information, article information, sent by executing this function, the detect document type. We can see that the research paper type is PDF, the article information is image, which is exactly what we need. The second step is to extract the contents of a file given the type. And we're going to use the LangChain library, which provides relevant module to perform this task. The first one is the unstructured image loader, which is specific to loading and extracting the content of image files. And the second one is unstructured file loader, which is mainly for extracting the content of other files like PDF, TXT files. And to do this, we have the second helper function. So this is going to first of all detect the type of the file. Depending on the type of the file, we use the corresponding module from LangChain. And this first one here is the PDF using the unstructured file loader. The second one is the image, in which case we use the unstructured image loader. And finally, depending on the loader, we load the exact contents of the file. And now we can join the contents of each page using the \n and return the exact content of the file. We run this one, and here we extract the content of the first one and the second file. And by running this, it's going to extract the content of each file. Okay, after running this, now we can show the first 400 characters of each document, and this is what we get by showing the first 400 characters. Here we have provided paper distribution is provided, and so on, to some of the information of the authors of the paper. And for the second document, we have as well the 400 characters, which is this document provide a quick summary until to advanced concepts. Now with this raw data, we can create the chunks of each document, and there are multiple strategies that can be used to create those chunks. In this specific case, we're going to use the character text splitter, and with this, by default, it's create the chunks by using the separator /n/n. There are a couple of additional parameters. The chunk size is telling us the maximum characters to consider in a given chunk. And here we are considering each chunk to be a maximum of 1,000 characters. The chunk overlap tells how many characters we want from the previous chunk to be in the next chunk. And here it is 200. This length function is basically going to identify the exact length, meaning the exact number of characters that we have in each chunk. And with this text splitter, now we can check on the chunk size of each of these documents. We can see that the research paper, which is a 5 pages document, is broken into exactly 51 chunks. And the second document, which is a 1 page image document, is broken into only 2 chunks. So now that we have the chunk of each document, the next step is to create the embedding of each chunk. And we can use that by using the LangChain embeddings that OpenAI, we import OpenAI embeddings. And before you do that, make sure that you have your OpenAI key available, because this OpenAI embeddings module is going to use the ADA2 model by default. And now we can, after running this, we have already the embedding available in this embedding. Let's just try to just show it. And as you can see here, it's providing some additional information about the model. This is the exact model that I was mentioning, the ADA version 2 model. This is where you can change the model name parameter. By default is ADA2, and you can also change the deployment type to provide ADA model. And here it's also text embedding ADA version 2. These embeddings need to be stored somewhere, and this is where the vector index comes into the equation. And to create the vector index, there are multiple ways of doing this. We can use Pinecone, ChromaDB, but in this specific case, we're using FAISS vector index. And to do that, I have implemented this getDocSearch helper function, which takes as parameter the text splitter and returns the corresponding vector search. And let's run this and execute the function and also print the exact docsearch paper. Now it's time to start the implementation of a logic to chat with each of these documents. And to do that, we have a couple of modules like OpenAI and also LogQA-Chain. So the first thing is to define the chain. What type of chaining logic we want the model to generate. And this is used by providing the LogQA-Chain function, which takes the OpenAI class. The chain type, in this specific case, we're using the MapReRank. MapReRank is going to rank the results by providing the highest, the one with the highest score. And intermediate steps, we set that to true because we want some additional metadata like the confidence score. And now that we have this, we can proceed with the implementation of the logic of a chat. Basically, we are putting everything in one function. The first thing is to extract the file content. Once we have the file content, now we can split that content using, this is the chunking chunking phase, document search by getting the search of the documents. And now the similarity is going to run the similarity search using the query provided by the user. This is basically the question that the user is going to ask. And once we have that similarity, we can use the chain that we have here, the input document and the question. These are the two parameters of the dictionary. And now we return the results of the intermediate step and getting the 0 index. So let's run this and see what it's going to provide. First of all, we're going to chat with the image file. And with my image file, this is the query that I have. What is the document about? This is this document. I want the model to tell me what this document is about. And after running this, I'm going to get the answer, which is going to be the results answer, and the confidence score is the score provided by the model. And as you can see here, the answer is that the document is about data science, machine learning, and machine learning operations. And we can see that this model provides a confidence score of 90%, telling I'm 90% confident that this is the answer to this exact query. Right, this looks like exactly the correct answer if we check this document, and yeah, it's exactly what the document is about. Let's perform the query for also this PDF file. And my question to the model is, why is the self-attention approach used in this document? So I want the model to tell me why we're using the self-attention approach in this research paper. Similarly to the previous one, let's run it, and it's going to provide the answer and also the confidence score. All right, so as you can see here, the model says that self-attention is an attention mechanism that relates first provides what the attention mechanism is, and then it tells that it is used in this document to compute representation of the input and output without using sequence align, RNNs, or convolution. Congratulations, you have successfully completed this tutorial. And now it's up to you to make any change and adapt to your specific case. And I will also provide the link to this notebook on my GitHub. The link will be provided in the description section below. Thank you for watching this video, and please subscribe and share with your friends. Also, let me know in the comments which topic you want me to cover in my future video. See you next time. Bye bye.